Good morning, you guys. I want to, before we get going into our lesson today, I just want to remind you if you do not have a graphing calculator to go to the link under the important info tab that gives you an opportunity to download a free graphing calculator onto your computer because we are going to be using things like inverse norm and things like that today. So I just want to give you a heads up. All right, so today we're going to actually talk about estimating a proportion. So in the last two lessons, we saw that a confidence interval can be used to estimate an unknown population parameter. We're often interested in estimating the proportion P of some outcome in the population. So like what proportion of US adults are unemployed right now? We don't have the official number for that. We can only send out a survey or get a sample and use that to estimate. What proportion of high school students have cheated on a test? Again, we could get a sample. We could ask a survey and make it anonymous and say, hey, have you ever cheated on a test, right? But we don't know the true number. What proportion of pine trees in a national park are infested with beetles? Like, you're not going to go to literally every single pine tree in a national park and say, yes, it's infested. No, it's not. It's too time consuming. It costs money. It'd be much better to take a couple random trees throughout the national park and make an estimation, right? So that's what we were talking about with these confidence intervals. So with confidence intervals, we have conditions to check, a lot like in Unit 6 when we had to do our conditions. The first condition is you just have to make sure it's random. Now, this sounds silly because basically all you're looking for in stats class is in the question, does it use the word randomly selected, right? Or a random sample. As long as it uses the word random, we are going to trust that the data was collected truly randomly. Same thing happens in AP stats, and I know that's kind of weird because we don't have more information than that. Moving forward, if you were to go like deeper into statistics and data analysis, post-secondary, that's something you have to make sure, how are you being random, okay? The other thing is we're using that large counts condition. So if you guys remember, NP is greater than or equal to 10, and N times 1 minus P is greater than or equal to 10. Notice how instead of P, they're using P hat. The reason is we do not know the true value of P, right? We're using a P hat, like a sample proportion, to estimate the true proportion. So we don't have that information like we did in Unit 6. So instead of in Unit 6, when we were able to check these two conditions, right? Now we're saying, okay, instead of that, we're going to use that P hat because that's the best estimate we have to work with, okay? Because we're trying to estimate the true P. So here's an example problem. So pause the video, read through it, and then we'll talk about the solution. All right, so they had they had a sample. This was a beads activity we were going to do together if we were in class together, but basically it's kind of hard to do that, digital learning, right? So they basically decided how many red beads versus white beads did they have in the selection, and they got that in their sample out of 251 beads, 107 of them were red, and so they got this as their P hat. So check if the conditions for calculating the confidence interval for P are met. Random, they used, right, the class selected a random sample of beads. Normally in the question, like if I showed the original problem, it would say they randomly pick out 251 beads or whatever it is, so you know you're good. And then large counts, here's our N, they picked 251 beads, and here's their P hat. That is, in fact, greater than or equal to 10, yay. For the other one, here's N, here's 1 minus P hat, which is also greater than or equal to 10, yay, okay? So that's just how you check to make sure, yes, we can now find a confidence interval using this information. So when we're doing confidence intervals, you already know that they're made up of these two parts, okay? The point estimate plus or minus the margin of error. When we're calculating a confidence interval for a population proportion P, the point estimate we use is the sample proportion P hat, mainly because, again, we don't know what P is. So our best guess for what P is our P hat that we collected. Okay, so a couple things we need to talk about. First thing is, don't forget from Unit 6 that the standard deviation of P hat is this formula. Okay, so just a little refresher from Unit 6. Okay, when we do those conditions, the ones we just talked about, the random and large counts, then we know that we can use normal approximation. So we can use normal CDF, things like that. And then these last two things, if you want to read through them, you can, but I feel like they might be kind of confusing without me explaining them. So let's do an example and just skip to the example because I think that will clarify what I'm trying to get to a little better. So, of course, we don't always go out 2 standard deviations in each direction. The number of standard deviations called a critical value depends on the confidence level. So here's what I mean by that. If we're doing a 95% confidence level, it's kind of like we're drawing a normal curve and saying, here's my p hat, and I'm going out plus or minus 95%. Well, if you remember, 68, 95, 99.7, this is between plus or minus 2 standard deviations. Okay, so what happens is the critical value depends on what your confidence interval is. If I wanted to do a 68% confidence interval, it'd be plus or minus 1 standard deviation. If I want to do 99.7, it's between plus or minus about 3 standard deviations and that sort of thing. So and it says the table. I don't want you to use your Z table at this point. I think technology is easier using your graphing calculator. To find the critical value, notice how it's Z asterisk. Okay, you'll see that a lot in this unit. For a 95% confidence interval. Okay, so I'm going to draw my curve. Here's my supposed p hat, right? And I want plus or minus 95%, right? Or 95% confidence that between this number and this number is my interval, okay? So what we need to figure out is what's basically the z-score that goes with these two values, okay? So if the middle is 95%, then this must be 2.5% and 2.5%. So here's what I'm going to do. I'm going to do inverse norm, okay? And I'm going to use inverse norm in my calculator, where the probability to the left is 0.025. Move the decimal place, right? The mean is 0 because I'm using that typical, like, mean is 0 and then z-scores are 1. And the standard deviation is 1. So I'm going to go into my calculator. If you don't remember how to type that in your graphing calculator, go second vars, which gets you to distribution. And inverse norm should be the third option down. So I type in 0.025, comma 0, comma 1, and I get -1 point, and here's what I'm going to do. I'm going to round to 2 decimal places, so -1.96. Okay, so here's what that means. Okay, if how I got this doesn't make sense, AP Stats students for next year, you need to know how this works and where that Z critical value came from. If you are just taking prob and stats and you're done, all you need to know is if you are doing 95% confidence, your critical value is 1.96. Okay, so if you don't 100% understand where I got that number from, as long as you have that written off to the side or memorized, you'll be just fine, okay? So here's an example of what that looks like. I'm going to skip through, but if you want to pause at this slide to get some more information, you can. All right, so here's the other thing we were talking about. Remember how standard deviation, I said, don't forget, this is our formula from Unit 6. Okay, here's the only thing this slide says. Since we don't know what P is, we're literally using P hat to estimate P. We're just going to replace everything where the true proportion was, and we're going to put P hat in its place, okay, because we don't know what that value is. All right, this formula is essentially what we're getting at. Okay, your point estimate, remember I said in the last video, is kind of like if I had to pick a number, a number that estimates the true proportion, I mean, P hat is going to be the number that's closest to what I have to work with. So there's your P hat. And then you're going to do plus or minus whatever that critical value was. That kind of lets you know how many standard deviations we're going out, whether we're doing 95%, 90%, and so on. And you multiply it by the actual standard deviation number, because that is what's going to give you that margin of error. If that doesn't make sense, let's do an example and see if I can clarify a bit. All right, so Dr. Godlewski's, yeah, you get the idea, class selected a simple random sample from her container of beads and got 107 red beads and 144 other beads. Okay, so we're looking for what's the true proportion of red beads. So in this case, their P hat is 107 out of Well, 107 plus 144 out of 251 beads. So it's the same p hat that we were talking about earlier in the video. So it's a p hat of 0.426. Here's what that means. If I had to estimate the true proportion of red beads, 0.426 is my guess. Okay, so I'm going to start with, well, my point estimate is 0.426. Now I need to figure out my margin of error. Well, since I'm using a 90% confidence interval, what I want to do is figure out what that critical value is. So AP Stat students, here's how you do this, okay? You do 90%, which is in the middle, which means there's 5% here and 5% here. So I'm going to type in inverse norm, 0.05, comma 0, comma 1. I'm just going to take a second to type that in really quick. And I get negative 1 point, and if I round, 645. So here's the deal. If you're not taking AP Stats, if you're not taking a stats class after this, if you have a 90% confidence interval, your Z critical value is positive 1.645. Okay, that's all. You just need to memorize it, and that's totally fine. If you're taking AP Stats next year, really think about where that number comes from. So 1.645 is my critical value. Now I need my standard deviation. So standard deviation of p hat is the square root of p hat times 1 minus p hat all over n, which in this case n was 251. So I'm going to real quick type that up in my calculator. You might even hear tap, tap, tap while I'm doing all this. And I get 0.03, I guess 1. So I'd multiply it by 0.031. So 1.645 times 0.031, I get a margin of error of 0.051 with that point estimate right here. That is my confidence interval. Okay, if you're wondering where some of those numbers came from, I'm going to go to the next slide where it's going to show the official solution. Oh, I guess I didn't have it. Never mind. But that's how you would calculate it. So you would say, I am 90% confident that the interval 0.426 plus or minus 0.051 contains the true proportion of red beads. Okay, that's kind of how that works. All right, so here's a practice question. Go ahead and pause, and then when you're ready to see the answers, unpause it. All right, show the conditions are met. Well, first off, is it random? And it does say the survey was given randomly. So normally I'd write random, question mark, and then I'd put a little check mark because it used the word random. Now we need to check NP is greater than or equal to 10, and 1 minus P is greater than or equal to 10. Okay, so N is 1416 times P, which is 0.36 in this case. That's 509.76, so that one's good. And then 1 minus 0.36, that number times the N value is 906. Both of them are good. I know I'm not showing everything, but I'm running out of time, so I just want to make sure I fit it in. Okay, here's the last thing you need to know. 99% confidence. How do we get that one? Well, so here's 99%. So this is 0.05%, which means it's 0.0005. If I do inverse norm of 0.0005, comma 0, comma 1. Oh, I apologize. I think I only want 2 zeros. That's my bad. There we go. I get a critical value of 2.575. Okay. Yeah. 575. So here's the deal, you guys. Remember, if you don't know where these numbers are coming from, okay, 90% is a critical value of 1.645. 95% is a critical value of 1.96. And 99% is a critical value of 2.575, okay? All right, there's no homework for tonight, but the homework will be posted tomorrow. There's no new video tomorrow. Your assignment is just to get Unit 7 homework number 2 done. Stop by during office hours if you have questions.